So here I present the research of on the parameters influencing the flow rate and power of a rotating volumetric pump. Here in this research, we present the original constructive solution for conveying some liquids with the help of a rotating volumetric pump. The pump can transport pure or suspended fluids, viscous fluids, polyphase fluids, and other kind of. Compared to reciprocating machines used to transport the same fluid flow rate, the energy consumption is lower at profiled rotating machines because the motor torque at the shaft level is almost entirely transmitted to the transported fluid. This means that the influence of rotor length, the radius, and rotating piston height on pump flow rate and driving power is noted. Afterwards, the influence of the functional parameters is presented by pump speed, the pressure increased between suction and discharge on flow rate, and pump driving power. The increase in machine speed is limited by liter per second. The effective efficiency of this machine, which can also be used as a fan or low pressure compressor, is clearly superior to other similar machines in the field of fluid flow. So in this case, this paper continues the theoretical and also the experimental research in the field of the rotating machines equipped with profiles rotors. This research aims to improve the actual efficiency of rotating machines. The efficiency increase can also take place by optimizing the interior architecture of these machines, where there are different shapes for both the rotating pistons and the shape of the rotors. To build the rotors, a calculation program was developed, and later the processing of the rotors was carried out at a numerical processing center. I want you now to give me a few seconds to show you the rotors. It can be. Can you give me 2 seconds to bring the rotors to show you physically how they looks like, or we shall continue?
Yes. Look.
Thank you very much.
Continue.
Just a second, please. Okay, if you allowed me to show you physically how it looks, the rotors on this new kind of pump. Okay. In this field of the fluid hydrodynamics, this kind of machines are divided into categories. Motor machine, in which the main purpose is to yield maximum mechanical work to the machine to be driven. Working machines, which must be constructed so as to absorb minimum mechanical work at the couple. In working machines, like fans, pumps, compressors, it is aimed to have a certain correlation between the internal architecture of the machine and the fluid flow parameters, as I shown before. In rotating machines, the motor moment received from the outside is in this mathematical formula. So the product between the force and the arm is maximum. This is a main advantage of a rotating machine with profiled rotors. as shown in the pictures in the tent. We state that the presence of blades on the rotor is a significant feature affecting the device performance. In the effect of geometry, as I shown before, and rotor speed on power consumption and shear rate profile in the investigated mixer is discussed. Okay. Considering the theoretical and experimental research carried out, this rotating working machine can be used in agriculture to compensate for the soil water deficit, ensuring the controlled supply of soil and plants with the amount of water according to the calculated soil moisture maintenance the regime, but also in pumping station to remove excess water from the soil and drainage. As this rotating machine can also transport dirty water with solid particles in suspension. The positive effect foreseen by the modernization of the land improvement is the improvement of the operating efficiency of the pumping aggregates, the reduction of electricity consumption, and implicitly the reduction of expenses for water pumping. Okay, just a second. Also, this rotating machine, depending on the material used in its construction, can transport food fluids such as oil, wine, alcohol, spirit, etc. The construction of the rotating machine with profiled rotors of the original shape could be constructed on a larger scale depending on the water requirement requested by the beneficiary. So now you here in these pictures seen what you have seen earlier physically, the rotors. Okay. And also it's explained the suction chamber. Okay. The lower case, lower rotor, upper case, and obviously the exit of the fluid. Okay. So here we have some mathematical calculations, and from which it results that at the same pressure value, the volumetric efficiency is higher in large size pumps because the volumetric losses increase more slowly than the flow rate increase. In low flow pumps, achieving high volumetric efficiency involves processing with high technological precision. So in the next figure, it shows the machine with the theoretical driving power of the rotating, where the total pressure increase achieved by the pump changes when the pump speed increases. Okay. So performing similar calculation, the values of pressure are obtained for the speeds, in our case, as we tried at 100, 200, 3, 4, 500 rotation per minute, as shown in the table lower. Okay, we made the three kind of different variant curve linear shaped pistons, and based on the data from the tables shown before for three kind of constructive variant, which was graphically represented earlier. Here we have a graphical representation of the function. Also, we show the velocity of the fluid, the friction between the pistons. So after all those kind of calculations, we obtain, here is shown in this table, the graphic of the power function required to overcome the friction as shown. Other performing calculations for the revolutions of the rotors. As shown, it's a lot of math here. So here, after all of this, the relations that determine the performance of this machine and the various operating regimes, different form of calculations are called the characteristics of the respective machines. The relations can be analytical, obviously graphical, and theoretical of this experimentally determined. So here in this graphic presentation, we have shown the flow rate for first variant, then the drive power, which can be also be higher. The pump flow rate varies as flows, but how we said before, depending on the geometric parameters and depending on the functional parameters. So in conclusion, the driving power is influenced by the flow rate, by the parameters mentioned above, by the pressure increase achieved by the pump between suction and discharge, by the nature of the fluid which is transported. The pressure increase achieved by the pump must overcome the hydrostatic load and the pressure losses that occur on both the suction circuit and the discharge circuit. Okay. So in the second variant with the pistons in the form of rectangular blades, other kind of pistons, the flow rate transported by the rotating machine will be the highest compared to variant 2 and 3 as we showed earlier. So we have shown that this new kind of machine increase the debit and increase the consumption of the energy, in our case, the electric energy. So in this moment, I thank you very much for your patience to see and hear my presentation. And I am waiting for your questions if anyone has something to ask, please.